Hey everybody, Johnny here. In this video, we're going to be looking at creating an animation like this. Now, you might think that this is going to be a pretty easy thing to do, but let me tell you that this isn't just an animation. This is actually an armature that's working in conjunction with geometry nodes, and that the text here is completely procedural. So, without any further ado, let's jump into this project because it's going to get kind of deep. So to get started, we're going to add a node tree to our default object, whether yours is a cube or plane or whatever you've got. As long as it's a mesh, you want to go ahead and add a node tree. So we'll open up a window here, we'll set it to node editor and click new. The first thing that we want to do is figure out a way to be able to control when we have some text. We want to control what letters are drawn and what letters are hidden. So let's start off with adding a text object. We'll go to Shift A and we'll add a text to curves node. We'll connect the string out to our input and just give it some sample text. And then we'll connect that to our group output. Now, when we output string to curves, it's actually creating curve instances, not directly curve geometry. We're going to want to realize instances before we go any further with these text curves. So now these are individual curves that we can edit the points in them. Next, we're going to want to hide the curves that come after the one we're drawing. And we're actually only going to want to show part of the one we're drawing. And really the only ones we want to show all of are the ones that are before the one we're currently drawing. So if I'm currently drawing the E here, I don't want the X and the final T to show up. The first T can show up, and the E needs to be half drawn. So what I'm going to do initially to get rid of the letters that we need either partially or completely gone is just to delete them from the geometry. If I do a geometry operations delete geometry, change the type to spline, which are the individual edges inside of a curve object, I then want to select which ones that I want to delete. Well, I've already said I want to delete all the ones past a certain point. Now each spline in our text has an index, and luckily for us, when we do text to curves, those march through the curves from left to right. So what we can do here is we can use the curve index and say any curve indexes that are greater than or equal to the one that we're currently trying to draw, delete those. And then any ones before that we can leave. So we'll add our index node. So now we're evaluating all of the indexes of all of the different splines. And we want to drag out here and add a compare node. And the one we want is a greater than or equal. And we'll connect that in. So now if I set this to 1, it's now showing spline 0. And 1, 2, and 3 aren't there. And actually, you'll see here that there are 5 because the E is made up of 2 splines. Now that we've made space to draw one of these letters, and we're going to have the other ones displayed, we can go ahead and delete all of the ones except the one that we want to draw. So I'll go back to my source of all of the curves. I'll copy my compare node, but this time I will change it to not equal. I'll reuse this same index node and I'll connect this up. For now, I'm just going to connect this to the output and eliminate the first one here. We can cycle through these and see that we're just getting one spline at a time. And if I change this to 1, 2 here and 1, 2 here, and then I join these two geometries, so I'll do a join geometry, you'll see that I get, when I'm on 0 on both of these, I get the first one. When I'm on 1 and 1, I get the outside of the E, 2 and 2, I get the inside. What do I want to do with the one I'm currently drawing? If we ever want to have a curve and just show part of that curve, by eliminating some of the beginning or the end of that curve, we can use a trim curves node. This gives you a control to say how far along the start should be and how far along the end should be. So I'm going to add a trim curve node, and I'll put it here on the curve that's left over in our drawing side of this chain. And we can see here, if I dial back the end of this, that gives us the effect we're looking for. So if I go back to spline 0 and bring this end back to 0, and then I bring up the end, you'll see that it draws spline 0. If I then go to number 1 and bring this back to 0, and then roll it up, it draws the next one. And that will work all the way through. For simplicity's sake, since this tree is going to get a little messy, I'm going to go ahead and group these nodes together. I'll connect the spline number controls to one of the inputs, and then I'll connect the end number to one of the inputs. I'm going to use the handy extension that's available just in the Blender extension platform, just in your edit preferences menu. There is an arrange nodes extension. I like it a lot. It lets you come in here. It adds a tab here. I can select all of my nodes and hit arrange selected, and it does its best to try to organize them for you. And for the most part, it does a pretty good job. Before I leave this node group, I'm just going to give this a name of draw curves. Since I'm just giving this a curve object that has multiple curves, I could give this anything. I don't necessarily have to give this text curves. But for this instance, we're just going to be giving it text curves. As a little edit here, before moving on, I did rename the group socket inputs for this node, and I gave it the name of draw curves. So just so if you see that different going forward, you'll see that's why. The next thing we're going to want to do is automate going from spline to spline through the factor each time. And for that, I'm going to use the simulation node. So under Shift A, I'll add the simulation node. I'll connect it up to my inputs and outputs and move my draw curves inside of it. Now what we want to do is for each of our splines, we want the factor to go from 0 to 1. So we're going to add, before the simulation starts, the value of 0. So the starting value for our factor. So I'll add a value node, and its value is going to be 0. We're going to take that value and we're going to actually plug it into the output value so that now that 0 goes from here to here, and then on each iteration of the simulation gets put back to the beginning. If that doesn't change, nothing's going to happen. So we do want to increase this after each iteration. And I'm going to give it a small number because our factor goes from 0 to 1. We don't want this to add up too quickly, so we'll do, say, 0.05 as our value to begin with. So now each time through the simulation, the factor value here is going to be increased by 0.05. We will take that value and we will plug it into our factor. And now for each step, the factor on drawing spline number 0 is going to get a little bigger. Let's run the simulation and see what that looks like. As you can see, nothing is happening. And this is a mistake that I made early on. Maybe you haven't made this mistake, but it's one to watch out for. You might think that this looks fine, when in actuality what's happening here is the first time through, we're deleting all of the curves, and the one we're drawing is at 0, and so we basically erased all of the curves. We've sent that to the output, and now we've sent that blank curve object back to the input, and we're trying to evaluate that, and there's nothing there. So the whole thing's gone. Instead of doing it this way, I'm going to remove this connection to the beginning of my simulation. And instead of feeding in this initial geometry, I'm going to feed this in from the outside. That means that every time through, our draw curves node is going to get the entire set of curves from our text, and then it will decide what to keep and what to throw away. And then that geometry will get sent to the output, so we see it on the screen, and then also get sent back to the beginning, and we discard what we did with the last iteration. Then our draw curves gets a new factor, and using the original set of curves again, generates the next frame's output. So let's see how that looks. And that's exactly what we're going for. Now what we want to do is say once we've gone from 0 to 1, we want to reset back to 0. We can do that with a compare node and a switch node tied together. So we have our output value, and let's add a compare node. And we can say if our factor is greater than 1, we need to reset our factor. So we'll use this to drive a float switch. So I'll add a switch and set it to float. So if this factor is greater than 1, so if this is true, we want the new value to go back to 0. If it's false, if we're still 1 or lower, we just want to use the value that we had just compared. We want to just keep increasing it. So we'll take this value and stick it in to the false. Let's see what that does. As soon as it gets to the end of the curve, it's jumping right back to the beginning of the curve. So there's one other thing we want to do when we jump back, and that's increase our curve number. So we can use this same greater than, because that's our trigger, but we need to trigger something else. We need to trigger adding 1 to our spline number. We'll do the same thing we did for the factor here. We will add an input integer that's set to 0. We'll connect that to the output, and we'll connect that to the spline number on our draw curves. We'll change this new switch to an integer, and we'll say when our factor is greater than 1, we want to add 1 to that input integer. So I'll add a math node and add 1. And then if it's false, if our factor is still below 1, we just want to stay on the current spline number. And so we'll take those and we'll send those back to the beginning. Let's see how this looks now. So that is doing exactly what we had asked it to do. And the beauty here is that if I come back and I change my string and go back to the beginning of my animation and hit the spacebar, you'll see that this is completely procedural. No matter how many curves are in this, it's automatically figuring that out and will continue doing this. You will want to make sure that your output frames are long enough to contain your entire animation. Now let's say we want to adjust the speed that these are being drawn. Well, for each step through the simulation, we've been adding 0.05. That's kind of an arbitrary amount, so it's going to take 20 steps to go through each of the splines in this curve. Now, that speed is going to be affected by the frame rate of your animation. So if you're running at, say, 24 frames per second, each curve is going to take about a second or just a little under a second to draw. But if you were running at, say, 60 frames a second, you would be drawing 3 curves every second. And so that's really not a consistent way to do this. So what we're going to want to do, we're going to connect this speed value to our input. I'm going to make a duplicate of our input here and bring it over and connect this to the value. So now I could set that 0.05 here from the value, and now I'm going to open up my side panel and I'll just call this speed. We want this speed to be frame rate independent. So that means no matter what we crank our frame rate up to or down to, this is still going to play out at the same speed. So this is where the delta time input comes in on the simulation. If we were to zoom out a little bit and say we were running at 1 frame per second, the delta time should be 1 second. But then say we are running at 2 frames per second, the delta time would be 0.5. And so that means to go the same amount running at 2 frames a second, we would want to add half as much each time. And as that frames per second increase, we want to add smaller and smaller chunks so that at the end of each second, we've added the same amount of chunks to our factor. So that means all we have to do is take that delta time and use it to scale whatever it is we're adding. So in this case, if we take this speed value that we've got set here at 0.05, and we scale that by the delta time, that means it's going to get chopped up into enough pieces so that later, if we were to change our frame rate, the speed of the animation would stay consistent. Or if your computer's having trouble maintaining a frame rate because your scene has become too complicated, that delta time will reflect how long it took from the previous frame and adjust its factor accordingly. So to do that, we're just going to duplicate this math node here, connect it to our speed, and then multiply that by the delta time. So if we play this through once, we'll see that it's very slow. But if we were to crank this up to say 0.1, we get about that speed. Now, if we were to go over to our animation panel and change the frame rate to say 120 frames a second, and then run that, for one, I'm capping out at about 60 frames per second, but you can see that it's still drawing at the exact same speed it was before. So now the speed of our animation is independent from our frame rate. Now that we have our curves drawing out, we want to create a way that we can track what point we're at in the drawing of the curves, so that if we wanted to control something to look like it was actually drawing those curves with like a pen or something, we could do that. So here's how we're going to approach that. First off, I'm just going to add a point to the scene, and I will just add a points node. And I just want to add 1 point. And I'm going to take this point and I'm going to send it out of the output of our simulation zone. And then I'm going to join that with the other geometry, the curves that are coming out of the simulation zone as well. So you can see I'm keeping these 2 lines of geometry separate during the simulation and then combining them into one output at the end. So you can see our point here has been generated and it's sticking at the position that it was generated at 0, 0, 0. So I'm going to want to move this each frame of the simulation. You might say, well, just change the position of my points node. Well, in a minute, I'm actually going to get rid of this points node, so I want to set the position after. So I'm going to add a set position node, and now we need to know what position we want to set. We can access all of the positions along any of these curves at any time. We also know what curve we're currently on, and we also know what the factor is along that curve. So if we use a sample curves node, we can ask the curves object about a certain position on a certain curve. So let's do that. We'll add a sample curves node, and then we need to determine what curves we're sampling. Well, just like before, we want to sample the original set of curves. So we'll take these realized instances and we'll sample those. Next, We don't need to input a value here because the value we want is the position, and that is given to us automatically. After that, we want the factor. So we want the current factor that we're at. So if we scroll back up here, we see that this is where we have our factor actually being generated. So I'm going to take this point and do a Control-J to put a little frame around this. Hit F2, and I'm going to put in factor. And just to make it even clearer, I'm going to come over here to my side panel, go to node, and then increase the label size. So now I've got a very clear indication of where I can get my factor from. I'll bring this down here and plug it in to the factor of my sample curve. Also, I need to know what curve index I want to access, and that was right here. I'll do the same thing, and I'll bring that down and plug it in. Now that I have this, I'm sampling a given curve at a given factor. That should give me the position that is currently being drawn. So I'll drag this over and set the position of this point using that value. If I go ahead and rewind back to the beginning of my animation with Shift left arrow, and I run it, it now appears that the point is the thing that's drawing the curves. Now that we have that, we want to use that point to drive other things in our scene that are outside of our geometry nodes. Because while putting everything in a single monolithic node tree can be cool, it really does leave a bit to be desired when it comes to doing animations or working with other things in your scene. So, because of that, we want to create an interface that allows something outside of the geometry nodes to track something that's inside the geometry nodes. And here's how we're going to do that. With my original object selected here, I'm going to go into edit mode. This will bring up the original object that I added the node tree to. And you can see, in my case, it was a plane. Yours it might be the default cube or whatever. What I'm going to do is I'm going to merge all four of these points down into one. So I'll right click here, go to merge vertices at center. So now this mesh object has one vertex. I'll grab my group input here, and I'm going to bring it down to here. And I'm going to replace the one point that I created with that vertex. So now if I rewind my animation, you'll see that that one vertex has jumped up to the start point of that first curve. And if I play the animation, it's that vertex that is tracing out my letters. Now here's an interesting thing with geometry nodes and mesh objects. As long as the vertices that are in your original mesh object are maintained all the way through to the end, you can reliably use them as indexes for other things. The thing we want to use this for is as a vertex parent. So what I'm going to do is I'm going to add an empty. Then I'm going to shift select the mesh that contains my node tree. And the vertex out here, I can use that to do my selection. So you can see that that mesh is the active object and the empty is the inactive object. So when I hit Control P, you're going to see that one of my parenting options is vertex. Since the vertex position has been altered from where it actually is in the object itself, you'll see that there is this parenting line from where the node tree is putting the vertex and the vertex is when there is no node tree attached. So what I want to do is I want to move the empty to where the the vertex is now with the node tree. And I can do that if I go to my search menu, F3, and look for clear origin. So this removes any offset between the thing that it's parented to and the child. So it's locked into place with that vertex. So now if I go in here and I press play on my animation, you'll see it's my empty that's parented to this vertex that's tracing out my letters. So now that I have a separate object that's being controlled by my node tree, I now have access to do anything I want that's outside of that node tree, like I would an object that didn't have geometry nodes on it. In the case of the example that I showed at the beginning with the robot arm, let's go ahead and add an armature and use the empty here as an IK target so that the robot arm will try to point to that target all the time. I'll go into side view, add an armature, and I will give it a couple of arm segments. Then I will move my 3D cursor to the end point here with Shift S, cursor to selected, and add a bone that's not connected to my armature. Then with that done, I'm going to make this end bone that's not connected. I'll make that the IK target. I'll do that by going into pose mode on my armature, clicking on what I want my IK target to be, shift clicking on the bone that should have the IK constraint on it, and doing Shift I to add an IK to the active bone. Okay, so now that we have that, we simply want our IK target to move along with this empty. And one way we can do that is by putting a copy location constraint onto our IK target bone. So with my IK target bone selected, I'm going to go over to bone constraints, add a copy location constraint, and set the target to the empty. So now my IK target should move along with the empty. The empty is vertex parented to the vertex that is being moved by my node tree, which is following along with the curves of the text that I put in. So let's press play and see how that looks. Of course, as the target gets further and further away from this arm, it's not going to reach anymore. So we might want a way to have the arm move along side to side with the IK target. And we can do that simply by moving this bottom bone along with the IK target as well. So if I put a copy location constraint on this first bone, and I set it to the empty, it's gonna make things go a little crazy, which is not what we want. We do want it to copy the X location of that empty, but not the Z or the Y location. So here, under my copy location, I just want to copy the X and not the Y and the Z. So now if I play this animation, the arm moves side to side along with that point, but it doesn't move along the y-axis or along the z-axis at all. One of the things that you're going to notice if I zoom in here, I'm going to turn the speed down a bit just so that we can get the effect that's happening. Once it gets to the end of this letter, watch what happens. You see here, it jumps down to the beginning of the next curve. So we have to find a way to gradually move between the end of one curve and the beginning of the next one. I thought one simple way to do this might be to extend our factor. So instead of going from 0 to 1, we'd go from 0 to 1.5. Now, we'd use the 0 to 1 for each letter, and then we'd use the 1 to 1.5 for each transition. And we wouldn't want to hard code 0.5 in there. We'd want to be able to extend that or shorten. So we're going to make an in-between length value that we can access. So jumping back up here to where our factor was calculated, here is our cutoff for 1. And so instead of this being 1 here, we want this to be some value that we're going to choose plus 1. So I'll copy this add node here and drag in a new value to it. And I'm going to call that Inbetween. And so we've got an in-between value plus 1. And now that's going to be our new factor cutoff. That's the value at which factor is going to return to 0, and we're going to move to the next curve. Now, when it comes to moving things or drawing things or whatever, this is only really going to affect that one vertex that we're moving around. And it's going to pause the drawing of the curves. So let's jump down to the section of the tree that is affecting the position of the vertex. That's this set position node here. We do need the current factor, so I'm going to grab that from over here. And we need to make a switch, and that switch will determine whether we are using positions from the curves to position our vertex, or if we are using something else to position our vertex. So when the factor is 1 or less, we're using the curves. And when it's greater than 1, we're going to use something else. So let's add a compare node. So when the factor is less than or equal to 1, we want to continue using the positions from the curves, which is this line that we've got coming in right here. So we want this compare node to control a switch. Add a switch, and this switch is going to be a vector switch because we're choosing positions with this. So when our factor is less than or equal to 1, when that is true, we want to just use the information from the splines. But when it's greater than 1, right now it's going to go to 0, 0, 0. So let's play this and see what that looks like. So we're getting those pauses that we want. But now we just need to determine what should we do during those pauses. The idea here is that we want to take the end of the curve that we're currently on, the beginning of the next curve, and figure out that line between those two. Then what we can do is just take a percentage of that line, starting at 0 and then moving up to 1, and take the points along that line during that time period. And we just put that in during that break, and then we switch back to the curves. How can we figure this out? Like we had done before, we're just going to sample these curves to get those 2 points. We want the end of the current curve and the beginning of the next curve. I'm going to duplicate this sample curve node. And of course, the curves I'm sampling are our initial ones here again. The curve that we want to sample is the one we're currently on, so I'll just bring this down as well. And now the factor of the current curve that we want is at the factor of 1. So we want the end of the current curve. Because we just got to the end of this curve, that's going to be the starting point of our in-between. So now this point is going to be the final position on the current curve. Now we want the first position of the next curve. So if I duplicate this sample curve, connect up the curves, connect up the index, but this time I add a math node and add 1 to it. Now I want the factor to be 0. So I'm getting the beginning of the next curve. This position is the end of the current. This position is the beginning of the next one. Since these are both vectors, if we subtract the first one from the second one, what we're left with is a vector that represents the distance between these 2 points. So let's go ahead and do that with a vector math node. I'll take the second point and add a vector math subtract node and subtract the first point. So this is that vector, this is that line that you could consider drawing a line between the first point and the second point, and then just taking that line and moving it down to so that the beginning of the line is at the origin. But the length of that line and the angle of that line are going to be the same as between those 2 points. So now I just want to take a percentage of this line. When we first start out, I don't want any of it. And by the time we're done with our in-between time, I want all of it. So I'm going to use a scale vector node. I can duplicate my vector math node and put it in scale mode. If the scale is 0, the length of this vector is going to be 0. And if it's 1, the length of this vector will be the distance between those 2 points. And now once we've created this new line that is some percentage of the original, we're going to add the original back in so it moves it back to the right position on the graph. And so to do that, we'll simply add back in the original position again. Let's take a moment to look at this vector math more closely, hopefully to help you understand it a little better. We're going to look at this in 2 dimensions instead of 3, just to make it a little easier. Let's say I have a 2-dimensional coordinate system like this. And my first point is at the coordinate x equals 1, y equals 4. And then my next point is at x equals 6, y equals 2. If I call 1, 4 my starting point and 6, 2 my ending point, if I subtract my starting point from my ending point, I get the difference between these 2 points. And so 6, 2 minus 1, 4 is 5, negative 2. So let's see where 5, negative 2 would be. Now, you might be wondering how this point is the difference between these 2 other points. Well, let's take a look here. If I think that the difference between these should look something like this, if I draw a line from the origin to the point that's the difference between these, you'll notice that these 2 lines are identical except their starting position. And if I were to add my starting point to both of these points, the point here at the origin would be back up here, and this point would be back up here. Now that this is coming out of the origin, I can very easily apply a scale to this. So like I said, this point is 5, negative 2. If I were to scale this vector by half, multiplying it by 0.5, I would end up with a new point. Half of 5 is 2.5. Half of negative 2 is negative 1. And so 2.5 negative 1 is right there. So you'll see that I've found the midpoint between my 2 points. And all I have to do is re-add my original point to that point. And I end up with the halfway point between my 2 original points. So I can do this with any value. If I were to multiply it by 0.25, I'd get a point here, which would then translate to a point here. 0.75 would give me this point. So this is what we're trying to do with this vector math, is we're getting the difference between these 2 points. The only difference is that we're doing it in 3-dimensional space instead of 2-dimensional, but the vector math still works. And then we are going to use that extra space that we put into the factor to decide what we're going to multiply, what we're going to scale this difference vector by before re-adding it back to its original position. So let's jump back over and see how we can figure out that new factor. One minor correction, I'm just going to fix this. I want the position, not the value, coming out of that socket. So I've got my first position and my second position, subtracting my first position from my second position, scaling it by some value, and then adding back my original position. So those are the steps that we just took on the graph. Now let's figure out what we want to scale by. If we take our factor, we're going to be dealing with it now when it's greater than 1. So we can get this new factor by subtracting 1 from the value. So if our in-between is 0.5, that means that this value here is going to be a value between 0 and 0.5. If we use that value to drive the scale, we would only ever get from 0 to halfway between the two curve points. So we need to map whatever that length of value is into a 0 to 1 space. So we've got 0 to 0.5, we need to go to 0 to 1. Now, in that very simple case, we would just multiply by 2. So we would take this value here, multiply it by 2, and then that would be our scale. The problem is this: we've made our in-between value something that we can alter. And so this multiplication value here isn't always going to be 2 to be correct. So we can find out what that number is. We can say how many times does our in-between value go into 1. So we can say 1 divided by our in-between value should give us this multiplier. I'm going to grab another copy of my group input and bring it down here. I'll take my in-between value and I'll set it to divide. And I will do 1 divided by our in-between value. So if our in-between value is 0.5, 1 divided by 0.5 is 2. If I put in 0.25 as my in-between value, 1 divided by 0.25 is 4. So this all works out. So now we're taking our value that is above 1 of our factor. This is our in-between time. We're then multiplying that by the inverse of our total in-between time. So we've got 1 divided by 0.5. And then we're using that to scale this difference vector. We're then re-adding our original position. So this should be the points in between the end of the first curve and the beginning of the next one. Here's the switch that was moving the vertex. So when the factor was less than or equal to 1, we were using the data from the curves. And when it was above 1, we were just using 0, 0, 0. So now we're going to say when it's above 1, we're going to use this new position that we've created. Let's go ahead and run this and see what it looks like. I'm going to turn down the speed a little bit so that we can see the transitions better. So that right there is looking really good. One thing we're going to want to do is to have these text curves be able to be rendered in some way. Now, you of course could do this by doing a curve to mesh and doing mesh outline. Another way you can do this, now that Grease Pencil is compatible with geometry nodes, is you could turn these curves into Grease Pencil strokes. So let's go ahead and do that. This top line here are our text curves. So I'm going to do a curves to Grease Pencil operation. you'll see we get a information warning here that non-instance curves are ignored. So that means we either need to convert these into instances, or we need to just uncheck instances as layers. Now you're going to get this big bubble around your area here, and that's just because these curves have a really thick radius. So I'm going to add a curve right set radius, and then I will determine from here how thick I want my strokes to be. Now that these are grease pencil, I want to assign them a material. And we currently don't really have any good materials to add. So out here in object mode, I'm going to add a grease pencil stroke. Now that I've done that, if I go back into my node tree, I'll see that I've got a bunch of materials that I can use with grease pencil. And so I'm just going to choose the black. So this is looking pretty good. The only other thing that I might want to change on this animation is that when it goes from one curve to the next, during that in-between time, I might want the end of this arm to lift up just a little bit as it goes to the next curve. So let's jump down here. This vector here is what is controlling that move from one curve to the next. So we could simply add a little bit of extra information to this vector during that time period. So if I add to this vector, I want to add some information to the z component of this vector. So I'll add in here a combine XYZ node, and this will allow me to mess with the z alone. The easiest way for this to move up and down would be to follow some kind of mathematical function like a sine curve. So let's go ahead and do that. So I'm not going to go into the math behind sine waves right now, but when you take the sine of 0, you get 0. When you take the sine of pi, you get 0. And if you take the sine of half of pi, so halfway between those two numbers, you get a value of 1. And it goes on a nice curve like that. So what we're going to do is map that factor that we have from 0 to 1 that we're using to go along that path between the two curves. And we're going to use that to drive a sine function. So if I take this value here, this is the factor that's been mapped into the 0 to 1 space. You would see as it goes between the two, it would start at 0 on the z-axis and move up to 1. So that's not what we want. Instead, we want this to go from 0 to pi. So I would simply need to multiply that 0 to 1 value by pi. And then we can take the sine of that value. Now, the only other thing we would need to consider is the values for sine go from 0 to 1, and 1 is way up here. So we might want to be able to control how high this actually goes. So we're going to want to multiply this result by some value, and that will be the top height of this transition point. And of course, this would be a good value to be able to control from outside. And so we could make that whatever we wanted to. So the only thing left to do here would be to rig up a model on the armature that we had created, or create a new armature around some other model. I have a video about how to rig up a robot arm, and so you might want to check that out. I'll put a link to that video down in the description, and it'll be at the end of the video here. But that will show you how to set up a good IK rig and some other nice features for a robot arm for this. But really at that point, the empty that we parented to the vertex in the node tree is available then for you to do whatever other animation or rigging that you want to do with it. The following of the curves and the text is all going to be handled by your node tree. So in conclusion, we looked at several really interesting things. First, we looked at how to do tracing of multiple curves. We learned how to use existing vertices from meshes as parents for objects that are outside of our node tree. And then we also learned how to interpolate between the beginnings and the ends of successive curves for something like this, or anytime we want to transition between two curves that aren't connected with another. This is one way we could attack that problem. So I hope in this setup you learned a few things, and that you might be able to take bits and pieces of this and put them in your own project. So as always, I hope this video inspires you to make something awesome. And until next time, I'll catch you later.